Hey everybody, welcome back to another map of the day. And the map today that we are going to be looking at is called Texcoco. So the way the map looks is that players start surrounding this big central lake. The lake is divided into 4 quadrants and each separated by these causeways that connect the outer lands to this middle island. So within this middle island we have a lot of relics, a lot of jaguars, and this central monument. Now, the center is walled off, so players won't have access to it unless they decide to invest into breaking the walls, or, since they start out the game with the siege tower, they can potentially hop over the wall to try and gain control of the monument at the expense of sacrificing the unit to the jaguars. And control of the monument in the middle is actually important because it provides a small gold trickle to the player which controls it, which is equivalent to about 2 relics worth of income. So, as we may be able to see by now, this map is pretty unique. And when we're thinking about how to make a map like this, we have to consider that bridges like these are a very situational thing. If you've ever played around with bridges in the scenario editor, we should know by now that the top end and bottom of the bridge is a separate object from the middle sections. So in order to make this work, we have to know exactly how many bridge objects would be needed to close the gap between this part and this part. And by association, when we make a random map of this, we have to make sure that the distance between the outer lands and the inner lands is always very consistent and predictable. So we will be focusing on how to recreate this map. So let's go over to the test script. So here we are in the test script with basically a skeleton script with everything that's here is just the constants of the things we will end up using. So right off the bat, we'll have the player set up the random placement because we can allow players to be anywhere along this outer ring. So we don't really care if they're super precisely placed. So now let's try and focus on how we could get this central lake and central island to be very consistent. So we can try a couple of things. So let's just try at the beginning to make the base terrain of the map be water. So we can go create land. The terrain type is going to be road fungus. Land percent is going to be 100, so it's going to take up all the area within specified borders. And so we'll make our borders, top border will be 40. And then similarly all the other borders will be 40. So we'll have a nice land in the middle. So the right border and the left border can all be 40. And then the player lands can be on the outside. So we'll go create player lands. This terrain type will be different. We'll have that be water for now, and we can change it later on. Land percent doesn't really matter too much because it's going to match the base terrain. So we'll just put that very small. And then we'll just give it a circle radius for good measure. So at this point we have the central land, and then the players are going to be on water. So in order to create the terrain which is outside, we can put that in the terrain generation section, at least at first. So we're here in the terrain generation section. So we'll say we want to spawn grass jungle on the base terrain of water. And then we want it to avoid spawning too close to this middle land. So we'll have a land percent 100. Number of clumps will be pretty big, and then we'll have a spacing to other terrain types attribute of, say, 13, so it'll stay a certain distance away from the central island. So let's try and see what that looks like, but in order to make this work, we'll put some player objects for the players so we can see where they would be spawning. So just have a town center and some villagers in the object section here so we can know where the players are going to be. So as we can see, we have created a nice central island, but it's a bit rough. So what we can do is give it an increased border fuzziness. So if we increase the border fuzziness to be very high, say 100, it should be a bit more consistent if we generate it again. See, it's a very consistent shape now, but one of the drawbacks of using a method such as this is that since we created the outside area as a terrain instead of as a land, we no longer have the ability to generate cliffs or elevation to distinguish between the water and the outer lands, because we should know by now that the elevations and the cliffs happen before the terrain generation section takes place. So if I were to try and create elevation on this outside area, we can try that. Let's create elevation 3. Base terrain can be grass jungle. Number of tiles can be 625, and then number of clumps can be, let's say, 16. And I wouldn't expect anything to happen here because prior to the terrain generation section taking place, there is no grass jungle at all. We only created that after the elevation was supposed to take place, so that's one of the drawbacks of using a method such as this. So we could potentially try something else. So the next thing we can try is we can set the base terrain of the map to be this grassy terrain, and then we can create the central lake as the first land, and then use the terrain to create the middle island because we don't really care to put elevation or cliffs on here. So let's try that next. So base terrain, instead of water, we'll have that to be grass jungle. The player lands can be basically the same way they were, except the terrain will be grass jungle also. And then instead of creating the central island, we'll create the central lake as terrain type water. And these borders will be slightly bigger, so we'll say 20% instead of 40%. And since we still want to have some consistency here, we'll keep that border fuzziness rather high. And then instead of creating grass jungle on water, we'll create road fungus on water. So let's try and see what that will do for us. So we can see that in contrast to the last method we tried, that we were able to distinguish between the lake and the outside terrain to be able to generate elevation and cliffs on our map. But the downside is that when we create this central land, it's no longer very round. It's actually pretty, I don't know what it is, squarish, octagonal, but it's not very round. And that has to do with how the spacing of the terrain types work when you compress a land in this direction. So this method doesn't really work super well for us either. So let's try again something else. So similar to the first thing we tried, we would want the central land to be created as a land right away so we can achieve a very consistent shape, but we also want a distinguishable terrain on the outside so we can be able to put cliffs and elevation on it. So let's do this. We will revert it to the way it was. So base terrain is going to be water again. We're going to create road fungus at the 40 borders. And then what we're going to do is we're going to keep the player lands as grass jungle, and we're going to increase the land percent to be 100. And the way we're going to deal with the separation is by other zone avoidance distance. So if the player lands had a zone of 1, which means all the player lands would be able to touch, and the only zone it would be avoiding would be zone 2, which is the middle. So if we specify our other zone avoidance distance to be 13 here, as well as here, then we could potentially get rid of this terrain statement, because at this point everything we need is being taken care of in the land section. So let's take a look at what this does. So similar to the first thing we tried, we have a very consistent shape for the central land, and we are able to distinguish between the outer terrain in order to allow the cliffs and elevation to be able to work. Now, if all we were trying to achieve with this is a consistent shape for the land, this would actually work out pretty well. But we also have to consider that we are going to be placing bridges on the map, which is going to add an extra layer of complexity. So we're going to try yet another method that's a little bit better. So we are in Madlands here. So instead of creating the central land as a single land, we're going to create it as a land pattern. So if we adjust our increment and our radius, we have a circular pattern of lands. And we can say, we can match those attributes. So it can have the terrain type of road fungus. It can also be zone 2, and we can also include that other zone avoidance distance when we create our land pattern. So if we copy these 36 lands and replace the one land that's here, that should give us a circular pattern. And then we would just need one more land in the middle here to fill in the rest. So in a similar way, we'll go create land. Terrain type is going to be road fungus, and then it's also going to be zone 2, and I think that should be okay. Also, I'll specify the land position to be right in the middle, 50-50. So now we have a very circular looking central island, and that other zone avoidance distance is working in a similar way. Now let's just take a minute to consider what we have with us here. So if we consider that we made a circular pattern out of 36 different lands, we can consider that we have a land here at 0 degrees, another one here at 90 degrees, another one here at 180 degrees, and another one here at 270. So we can use the lands in these 4 quadrants to then later on reference our bridges to it when we are creating those in the objects section. So that was part of the reason that we also use that circular pattern. Is going to help with the bridges later on. So in order to pick out which lands are going to be at 0, 90, 180, and 270, it's going to be actually relatively easy for us because at least one coordinate is going to be 50. So we will just pick those out and assign those to have different land IDs. So the first one at 0 degrees is going to be land ID 1. And then the next one, which is going to be at 90 degrees, is going to be here because the x coordinate is 50. This will be land ID 2. And then the next one would be at 180 degrees, which would be this land here, land ID 3. And then the one at 270 degrees would be this one over here, which would be land ID 4. And then for the central land, we can also give that a land ID. So we'll just give that land ID 99. So I suppose we can now focus on how we can make the bridges. So we have the constants for the bridges up here. So like one of the bridge A and bridge B are going to be facing different directions. So I think bridge A is going to be facing this way, bridge B is going to be facing this way, and then we have top and bottom objects as separate from the middle objects. So let's start in the objects section, and we can work on the rest of the map later on. So if we want to make the first bridge, we'll just tackle the first one at 0 degrees, which is going to be on the right side of the map over here. So if we go down here, we'll just make this the right side bridge. So which one was that? It's bridge A bottom. So if we create object bridge A bottom, we want to reference it to the land ID number 1. So we'll say place on specific, and we want to find closest. So let's just see what that does for us now. So as we can see, we have precisely placed that bridge object on land ID 1, which was at 0 degrees in our land pattern. But we would not want it to start it here. We would actually want it to start a bit further out. So we would need to find a way to keep it from spawning too close to this land ID. And for that, we will try something. So let's consider that we still have a central land here. So if we were to put an object on the central land, give it an actor area, we should know that actor areas are represented as squares. So if we can see these dashed lines here, if these were representing actor areas, we could keep the bridge objects that are spawning on these nodes here from spawning too close to the middle. So let me try and explain better what I'm getting at here. So I will use an off-grid object. So 647, and well, first thing we're going to do is create that object, and we'll say similarly place on specific land ID, which is going to be 99, which refers to the central land. Want it to max distance to players is going to be 0, so it's going to be spawning right in the center. And then we will give this an actor area 1, and we'll give it a certain radius. So let's just say 10 for now. So then, with that actor area in place, we can try to get this bridge object to avoid that actor area. And we can say avoid actor area number 1. And then, just for debugging purposes, we can place some more objects. So we'll create object create many flags within that actor area. So actor. This is just going to help us see where that actor area is going to be. So let's restart. And as we can see, we have flags in our actor area, but it's not quite big enough to push this bridge object over to where we would need it to be. So let's try and increase that actor area a bit from 10 to 15. So now let's take a look at what we have. So now that we have a bigger radius, we can see that the bridge object is pretty much where it's supposed to be now, where we can see that it's now starting at the edge of the water instead of starting at the origin of that land. So in order to place the other objects of the bridge, we can use a similar thing. So if we had the next object, which would be bridge A middle, that will also be placed on specific land ID 1, find the closest spot, but we'll place another actor area in the very same spot, but we'll make that radius 2 units bigger, 17, and we'll have that actor area be 2. So instead of having this middle section avoid actor area 1, it'll avoid actor area 2. So if we try this, she was able to place that middle section in the correct spot also. And so, in a similar way, we can keep making actor areas and keep making those next bridge objects avoid those actor areas. So for this map, we would be needing at least 6 middle sections before we get to the end. So we have 1 here, 2, 3, 4, 5, 6, and they will all have to avoid actor areas. So actor area 3 will have the radius of 19, which is 2 units bigger. And then we'll have actor area 4 has the radius of 21. 5 will have the radius of 23. 6 has the radius of 25. And then 7 has the radius of 27. So this avoids actor area 1, actor area 2, and then similarly 3, 4, 5, 6, and 7. So we have our 6 middle sections here, and then we can put the end on. So instead of bridge A bottom, we'll instead go bridge A top. And then we would need 1 more actor area here. Number 8, radius 29. And so this can avoid actor area number 8. So that's basically how that works. So if we wanted to make the bridges on the other 3 sides, we could do something that's very similar. And we would use, instead of bridge A, we would use bridge B for these sections here and here. So we could do that, but the next thing I want to focus on is that we have now optimized our map for being a 2-player size. So what would happen if the map was bigger? So let's try and look at that. So instead of a 2-player size, we'll make it a 8-player size map, and we'll see the differences. So all of a sudden, we can see that now what used to look like a lake now looked like a really small puddle because that zone avoidance was optimized for a 2-player sized map. And then also notice that the bridges are no longer in the right spot because the distance between the center and the edge of the island is different now that the map is bigger. So let's try and see what we can do about this. So let's first address how we are going to make this lake a bit bigger. So our zone avoidance between the middle and the outside is optimized for a 2-player size map at 13. So if we were to do something else, like this, we could say if it's a tiny map, the zone avoidance can be 13. If it's a small map, the zone avoidance can be 2 units bigger, 15, medium map, and then so on, so that when we have what we have now, which is a huge map, the other zone avoidance would be 21. So if we replace our zone avoidance here, and then similarly all the other zone avoidance over here, we should be able to see a bigger lake in a situation like this. So let's take a look. So now the lake looks considerably bigger than it did, but we still need to fix the bridges. So the way to do that is to increase the sizes of the actor areas that we will be using. So if we go and we look at the first actor area that we have, 15, that'll be, if it's a tiny map, that actor area radius can be 15. But if it's a huge map like we are seeing now, the actor area radius needs to be bigger, because that first bridge object is going to be starting farther away from the center of the map. So that actor area radius is going to be 25. But then similarly, if we have our actor radius starting out at 25, then the sequential radii of the next actor areas have to be 2 units bigger than this instead of 2 units bigger than this. So as we may be able to tell, these actor area radii are going to be very dependent on what map size is being used. So we would have to go through and test to make sure we have the right sizes, but for demonstrative purposes, I found them all out beforehand. So we have all of our actor areas specified in these commands here. So I'll just replace these with the ones over here. And let's see, in the huge map category, we have radius 25, 27, 29, 31, etc. So it should be starting in the proper place now. So we can see it starting in the proper place, but we can also see that since we increased the size of our lake, now we don't have the correct number of bridge objects, and we're falling short, and we're not quite reaching the other side. So it should also be apparent that the amount of middle sections of the bridge that we would need is also going to be dependent on the map size. So in order to make that happen, what I'm going to do is that at the top of the map here, I'm going to put this little thing that checks what size is the map. So if the map is huge like we have now, it means it knows it's at least tiny, at least small, at least medium, at least large, at least huge, so it can know to place the additional objects. And the reason our other zone avoidance distances here are in increments of 2 is because we know that the bridge middle sections are 2 units long. So that kind of helps us to know that we need 1 additional middle section for each size increment of the map that's increased. So if we go down to where we have our bridge sections here, we can say this is where the middle section stops. So we need an additional middle section if the map is at least small. So if at least small, then we would need another section. And then if the map was at least medium, we would need an additional section. If the map was at least large, and then huge, gigantic, we would need additional middle sections. So that avoids actor area 7, and then we would need actor area 8, 9, 10, 11, and then 12 to make sure that they are spawning farther away. And if we look at our actor areas that we defined up above, we have more actor areas that come into play when the map is bigger, because we will need more objects. So actor area 12 has the radius of 47 in the huge map case. So that corresponds to this middle section here. And then finally, the end of the bridge is going to be in a different place depending on the map size here. So it avoids actor area 8 when the map is tiny. So actor area 8 has the radius of 29. So we would need to get this end to spawn farther away when the map size is bigger. So it's a tiny map, then it avoids actor area 8. Else if small map, medium, large, huge, gigantic, and the actor area it would need to avoid would be bigger with each map size. So you'll be avoiding 9, 10, 11, 12, and then 13. So let's take a look at what that looks like. So we can see that because we have our variable actor areas and we have these different cases for each of the bridge objects that we would need, we can now see that the bridge is spawning at the correct length with our increased map size. So I hope all this is making sense, but basically to sum it up, we need to check for the map size in order to know how many middle sections of the bridge that need to be placed. And we also need to check the map size in order to figure out how far away the objects need to be spawning away from the middle of the map to determine the actor area radii that we will be using. And so that just takes care of the bridge on one side, and if we did the same thing, we would be able to have the other three bridges. So I'll just paste those in, and we, instead of place on specific land ID 1, we place on specific land ID 2, 3, and 4, and then where we need to, we switch from bridge A to bridge B, and so on. So this is the map with all 4 bridges in place, and now we can start to work on creating the rest of the map. So we'll just be copying and pasting from the official map. So let's take a look at the terrain section. So we just have some aesthetic thing going on first, which is masking some shallow on the water here. And then next thing we're doing is we're creating dirt 2 on the middle island. So if we take a look, we should be able to see a small strip of road terrain that still exists with the dirt 2 over here. And then we can cover that back up with rock terrain, which is going to be space into other terrain types 1. And that's going to leave us one tiny strip of dirt 2 in order to place walls later on. And it's also going to make it so no one is going to be able to build anything in the central island. So that does that, and then the rest up to that point should be pretty much nothing special about that. So we're basically recoloring the terrain in the middle, adding some forest in the middle as well as on the outside, and yeah. So this is basically what the map is going to look like after the terrain section has been taken care of. So we have some extra decoration in the middle, but it's still being rock terrain. so we won't be able to build anything on this. And then we have forests on the outside with some terrain decoration in here also. We skipped over the elevation and cliffs section, but we can put those back in. Nothing too special about those. And then we can keep moving on with the objects section. So if we go into the official map, after the bridges are done, the next thing to be done is put some wall objects on the Dirt 2 and then create a monument in the middle. So the wall is being placed on Dirt 2, and we only have one single strip of Dirt 2. We're just going to be placing walls there, and then the walls have an actor area so we can keep objects away from them later on if we need to. And then in order to place the monument, we need to have a placeholder object because, of course, we made our middle unbuildable terrain, so we would need to have a placeholder object for the monument, and then the monument is created using the second object attribute. So we have our walls created here, and we have a monument also, but let us set the Gaia civilization to be different because this is supposed to be a American theme, so we'll set Gaia civilization to 15, I think. That's the Aztec civilization. Yeah, that's right. So now it looks a bit more theme appropriate. So next, we want players to be aware that there is an important monument in the middle of the map. So we'll create map revealers for the players, which are going to be placed on the same actor area that the monument has, which is radius 0, and then some loot objects for decoration, and then the jaguars and the relics are going to be referenced to the center of the map. So we can copy these objects over, and take a look at what that looks like. So we have our loot and our relics and our jaguars here, and then the rest is just basically player objects and some extra decoration. So we can just copy the rest here, and basically this should be our completed map in terms of the way it looks. So that's basically the way it looks. So the final thing that we would need to do in order to complete this map is we have not yet made it so that the player that controls the monument will receive a gold trickle when they are controlling it. So if we recall, back when we made the map City Siege, we also dealt with monuments that enabled a resource generation, and that was done by creating object 1639. So if we spawn that object, that would make it so that the monument would generate each wood, food, gold, and stone for whatever player controls the monument. Now let's try and think about why that is the case. So we are here now in the Advanced Genie editor. So let's take a look at object 1639. So this says it's a monument resources enabler, and if we scroll down here, we can see that it initiates some technology, which is 729. So if we go into the text tab and we look at 729, that has an effect of 764. So in the effects tab, we'll look at 764 and let's see what that does. So basically, it sets a resource in the game to a value of 1. So initially it's 0. So it does that 4 times. And intuitively, that should mean 1 resource for each resource in the game correspondingly. And then the final thing it does is just gets rid of the object that placed it, 1639, by setting its HP to -1. So now that we know this, if we were able to pick and choose which resource to set, we could be able to pick and choose what resource the monument would be able to generate when the player controls it. And lucky for us, that's actually something we are able to do. So to a very limited extent, we are able to use a random map script in order to modify the game's data using the command effect amount. So this command was introduced in user patch 1.5, and the capabilities back in user patch were a bit more versatile than they are currently in the definitive edition. And if it ever becomes more relevant, I may make a more comprehensive video on what this actually means. But for our purposes here, it just basically means we are able to modify a certain resource, like that object is doing 639, but we're only going to do it for 1 resource instead of all 4. So the syntax for that, first of all, it must be in the player setup section. So that goes effect amount, and we're going to modify the resource, and we're going to choose the resource that we're going to be modifying. In this case, 224 is the one for gold, and then food, wood, and stone are over here also. So we're going to be modifying that gold generation resource. We're going to be setting it as opposed to adding to it, which we could have done, and the value that we're going to set it to. So object 1639 would set it to 1, so we will similarly set it to 1. And if we restart our map, we could be able to bring a unit over to the monument and see what it does. So we can see that our unit has now captured the monument, and instead of a trickle of all 4 resources like would be possible by generating object 1639, we are now only receiving gold because we decided to modify only that 1 resource instead of modifying all 4 like was done over here. And similarly, we didn't have to just set it to 1. 1 is basically the lowest it can go, so we can actually set it to any integer value, and if we were to increase that to, say, 10, we could get a faster accumulation of gold than we were if that resource was only set to 1. So just like that, now that our resource value was set to 10 instead of 1, we can see that that gold accumulation is happening much more quickly. So that basically does it for what I wanted to share with this map, and hopefully you've learned something. So yeah, thanks for watching.